Welcome, and thank you for joining us with the 2016 California Building Code as we present Means of Egress Part 1, Fundamental Requirements. On behalf of the Los Angeles Basin chapter of ICC, we'll be spending some time discussing some of the general requirements contained within the California Building Code, which is based on the 2015 International Building Code with some important amendments that apply to projects located in California. This educational webinar is part of a series of short training elements provided by the Los Angeles Basin chapter of ICC to assist individuals in gaining a better understanding of the 2016 California Building Code. For convenience, each subject is presented in one or more short segments that last approximately 30 minutes or less. Viewers may watch the webinars at their own pace in any order that makes them comfortable. Designers, builders, and code officials are welcome to use this information to bolster their own familiarity with the California Building Code, but are reminded that interpretation and application of the code are reserved for the individual responsibility of the local jurisdiction. This webinar is the first component of a four-part series that will cover the important topic of means of egress. Today we will examine the fundamental requirements of Chapter 10, Means of Egress, which apply to all elements of the means of egress system. The remaining webinar components in this series will present further details specific to exit access in Part 2, exit and exit discharge in Part 3, and doors, door hardware, and special egress controls in Part 4. Okay, let's get started. Before we begin, let's make sure we all have a clear understanding of the purpose of a building's means of egress system. While there are many aspects of a building which contribute to occupant safety, the ability to get out of the building and away from danger is paramount. Therefore, every building or space which is normally occupied shall be designed and constructed in a manner which ensures that occupants are reasonably able to self-evacuate in order to reduce exposure to hazards. Note that the purpose of the means of egress system focuses on areas that are normally occupied. While people may enter spaces that are not normally occupied, such as attics, crawl spaces, storage closets, and the like, it is not the intent of the code to apply stringent egress requirements to those spaces because they are not likely to be occupied under normal circumstances. Also note that the objective is not to make a building absolutely perfect and risk-free. The means of egress system provides occupants the opportunity to be reasonably able to self-evacuate in a manner that will reduce their exposure to a developing hazard within the building. The means of egress for a building is composed of a system that consists of three components. Those components are the exit access, exit, and exit discharge. While these egress components may often seem very similar, each component serves a different purpose and protects occupants in a different manner. Understanding the distinct purpose of each component is critical to ensuring a safe building because occupants may need a different mode of protection depending on where they are. Protection of a person located in a large open room may utilize different design strategies than a person located inside a fire resistance rated stair shaft or located outside of a building on an exterior exit balcony. So let's take a quick look at the purpose of these three components, starting with exit access. Exit access is defined as that portion of the means of egress system that leads from any occupied portion of a building or structure to an exit. Next, the exit is that portion of a means of egress system between the exit access and the exit discharge or the public way. Exit components include exterior exit doors at the level of exit discharge, interior exit stairways, interior exit ramps, exit passageways, exterior exit stairways, and exterior exit ramps and horizontal exits. Finally, exit discharge is defined as that portion of a means of egress system between the termination of an exit and a public way. Graphically, we can see how the three components work together by considering the man on the fourth floor of this building. Features designed and constructed into the building will lead him to an exit. Those features comprise the exit access. Once the woman enters the interior exit stairway enclosure, the exit component will provide her with a safe, protected, and continuous path extending from the exit access all the way to the exit discharge or the public way. Finally, the woman at the bottom has reached the termination of the interior exit stair and advances further away from the building until she reaches the public way. This final portion is the exit discharge. So now that we've seen how the three-part means of egress system works, let's take a look at some common elements of an egress system. Each of the three components may be comprised of one or more individual elements. Typical elements of an egress system include such things as doors, exit access ramps, interior exit stairs, exterior exit balconies, exit courts, corridors, exit passageways, horizontal exits, areas of refuge, and many more. The minimum design standards for each element within the egress system are different, and collectively they work together to ensure an effective egress system. So it sounds simple enough, right? Well, consider this. Do all egress systems include each of the three components? Do all egress systems include an exit access, an exit, and an exit discharge? When designing a building or performing a plan check prior to permit issuance, or when conducting a building inspection during construction, how do you know which part of a means of egress system you're in? Who decides which part of the means of egress system you're in? How do you determine what level of protection is required? These are all important considerations because a designer should not be expected to integrate exit features into a portion of a building that serves only as an exit access component. Similarly, once building occupants reach the exit discharge, most protection features associated with the exit components are no longer mandatory. As long as code limitations for each individual component are not exceeded, the designer is entitled to determine which egress component is used within the building. Let's take a look at how egress systems work. To properly design any of the egress components, it's important to understand how the entire means of egress system works together. Ask yourself, what is the function of each component? How do multiple egress components work together? Remember, we're considering not just an exit, but an entire means of egress system. Consider, what is the ultimate objective? Well, at its most basic, the ultimate objective of every egress system is to safely facilitate the effective and orderly self-evacuation of all building occupants under conditions which are reasonably likely to occur at some point during the building's anticipated life cycle. So before we get into some of the technical aspects of means of egress, let's take one final look at how multiple egress components work together. First, before a building's means of egress even comes into play, occupants are informed that there is a need to evacuate the building. This may result from the actuation of a building's alarm system, or due to shared information among other building occupants, or the individual may observe a developing hazard with their own eyes. Here's where the means of egress system starts to function. First, it enables occupants to find an exit in a safe, effective, and orderly manner. Second, it protects the occupants if they will remain inside the building for an extended period of time while they progress toward safety. Third, once out of the building, it facilitates dispersal of all occupants away from the building so they do not hinder the ability of others behind them from also leaving the building. The exit access is the portion which enables occupants to quickly and effectively find an exit. The exit protects the occupants if they will remain inside the building for an excessive period of time before they get out. The exit discharge facilitates dispersal of occupants away from the building to avoid congestion. So as we can see, occupants commence their evacuation within the exit access as they maneuver themselves through occupied building spaces in search of an exit. Once they find an exit, a significant level of protection is provided because it may take them a while before they reach the end of the exit and emerge from the building. Once outside of the building, exit discharge features provide further safety by facilitating dispersal of people toward a safe location, such as a public way. So now let's take a look at some general requirements that apply to all egress elements. The entire means of egress system is only as strong as its weakest link. Regardless of the location within the egress path, individual elements are all required to meet minimum standards, and in this way, they fit together to ensure an effective system. These minimum standards address issues such as clear space necessary to provide sufficient height and width along the egress path, obstructions and protrusions which may extend into the egress path, doors and door operations along the entire length of the egress path, illumination to ensure that occupants can see where they need to go, walking surface characteristics to ensure that people don't slip, trip, or fall while trying to find their way to safety, number and location of exits to ensure a safe and effective distribution that will accommodate all of the occupants within a building or space, exit signs to effectively direct occupants to safety rather than require them to search during an emergency situation, emergency escape and rescue openings from sleeping rooms to ensure that people aren't trapped if a hazard develops while they are asleep. Let's start with ceiling height and obstructions. To ensure that occupants can safely and rapidly progress through the means of egress system without unexpectedly hitting their heads or other parts of their bodies, the means of egress system shall have a minimum ceiling height of not less than 7 feet 6 inches. There are a few exceptions which allow for some reasonable deviations as follows. Portions of sloped ceilings and ceilings within residential occupancies are allowed to extend lower than 7 feet 6 inches in accordance with Section 1208.2. These are generally areas along the perimeter of rooms, which often accommodate furniture and are not likely to be part of the normal circulation path. Projections such as ceiling light fixtures, architectural embellishments, and structural components are allowed to extend down to 6 feet 8 inches, provided such projections do not exceed 50% of the width of the space. Within parking garages and mezzanines, the ceiling height may be reduced to 7 feet 0 inches. Finally, at stairs, ramps, and doorways, the minimum clear height may be reduced to 6 feet 8 inches, with further allowance that door closers and door stops may extend an additional 2 inches to 78 inches above the walking surface. Careful planning can help avoid some common problems as seen here. The minimum headroom clearance at stairs is often a problem due to framing errors or when the thickness of stair tread finish materials is neglected. As seen on the right, the distance between supporting floor joists by bearing directly on top of a beam versus framing the joist flush by using joist hangers can make a big difference. While the underside of door stops and door closer devices are allowed to extend down to 78 inches, modifications to standard hardware as shown on the right may cause portions of the door closure to project even lower than 78 inches. The minimum clear width of most means of egress elements is determined on the basis of occupant load. Additionally, since people naturally require more time to move vertically downstairs compared to the time necessary to move horizontally across a flat floor, the code establishes a slightly wider standard for stairways compared to all other egress components. Essentially, the larger the number of occupants that must fit through an egress component, the wider it must be to prevent a bottleneck. For stairways, the minimum width in inches is determined by multiplying the occupant load served by a factor of 0.3. Hence, an upper floor of a building with an occupant load of 800 people would require a minimum width of 800 times 0.3 equals 240 inches of total egress stair width. For stairways serving other than Group H and I2 occupancies, the minimum width factor is reduced to 0.2 inches per occupant when the building is equipped with both an automatic sprinkler system and an emergency voice alarm communication system. For Group H1, H2, H3, and H4 occupancies, the minimum width factor for stairways is 0.7 inches per occupant, in recognition that the extra width may enable more effective egress from hazardous occupancies. For other than stairways, the minimum required width in inches is determined by multiplying the occupant load served by a factor of 0.2. Hence, a large auditorium with an occupant load of 1,000 people would require a minimum width of 1,000 times 0.2 equals 200 inches of total egress width from the room. For other than Group H and I2 occupancies, the minimum width factor is reduced to 0.15 inches per occupant when the building is equipped with both an automatic sprinkler system and an emergency voice alarm communication system. For Group H1, H2, H3, and H4 occupancies, the minimum width factor is 0.4 inches per occupant, in recognition that the extra width may enable more effective egress from hazardous occupancies. To reduce the likelihood that objects protruding from walls will interfere with effective circulation, horizontal projections are limited to a maximum of 4 inches when located between 27 inches above the walking surface to 80 inches above the walking surface. The purpose of limiting horizontal projections is primarily to assist visually impaired individuals and to prevent obstructions from slowing movement within the circulation path of an emergency. For consistency with accessibility standards, handrails are permitted to protrude 4.5 inches from a wall, and special provisions are also included in the code for Group I2 occupancies to allow for gurney movement and alcohol-based hand sanitizer dispensers. Here we can see some examples of typical problems and some solutions. These drinking fountains are located between 27 inches and 80 inches above the walking surface, so they should not project more than 4 inches from the wall. Here we can see that the drinking fountains have been recessed out of the circulation path, and as long as the alcove is deep enough that the drinking fountains project no more than 4 inches beyond the alcove into the circulation path, the installation is acceptable. Here we see a wall-mounted fire extinguisher cabinet that projects more than 4 inches away from the wall. Use of a recessed extinguisher cabinet would have solved this problem. Alternatively, a wall-mounted extinguisher cabinet can be installed in an alcove outside of the circulation path, thereby avoiding an obstruction problem. Proper walking surfaces are another important aspect of egress systems. Unfortunately, the consequences when even a single person trips, slips, or falls, while others behind them are also attempting to flee from a hazard, can be severe. So, what's required? Section 1003.4 establishes that walking surfaces of the means of egress shall have 1. A slip-resistant surface, and 2. Be securely attached. But even with a properly secured, slip-resistant finish, people can still stumble if elevation changes are not properly addressed. To avoid problems, elevation changes less than 12 inches in height must be sloped, and slopes greater than 20 to 1 shall be by a ramp. In most cases, common sense and good judgment provide sufficient guidance to avoid floor surface problems. If you unexpectedly find yourself fleeing from a hazardous situation, especially in an unfamiliar and marginally illuminated environment, the last thing you want to encounter is a slippery surface, an unexpected vertical step, an abrupt change in floor elevation, or grossly irregular surface. Speaking of marginally illuminated environments, how much illumination is required? It turns out that the human eye can discern quite a bit of detail with just a little light. Accordingly, normal illumination within the egress path is sufficient as long as the intensity is not less than 1 foot candle, measured at all points along the walking surface at all times in which the space served is occupied. Under normal conditions, illumination power shall be provided by the premises electrical power system, which ensures constant illumination at a consistent intensity. But in the event of a power failure, certain areas within the means of egress are required to have an emergency power supply which will provide all of the following. Emergency generators or batteries shall last at least 90 minutes. Emergency lighting shall supply an average intensity of at least 1 foot candle throughout the means of egress, with a minimum of 0.1 foot candle intensity at all points along the walking surface. At the end of 90-minute duration, emergency power shall still be sufficient to provide an average intensity of 0.6 foot candle with a minimum of 0.06 foot candles at all points. The maximum to minimum illumination ratio of 40 to 1 remains in the code, which is intended to prevent emergency lighting fixtures to be installed in a manner that results in areas that are exceedingly bright or dim. The reason that emergency lighting is subject to a maximum-minimum intensity ratio is that most emergency lighting is accomplished through dedicated lighting fixtures instead of general lighting equipment. High-intensity emergency lighting is very popular because it can broadcast light over a very broad area while using fewer devices. Unfortunately, if they are spaced too far apart, the walking surface immediately below the units can be extremely bright, while the intensity drops off further away. Just as our eyes need to adjust when you walk into a dim movie theater, vision can be impaired if the egress path passes through very bright spots to dim locations. Often, the only way to evaluate this during a building inspection is to cut building power and measure the lighting intensity during nighttime hours. So where does the egress illumination require emergency power? Emergency illumination power is required in rooms and spaces that require 2 or more means of egress at aisles, corridors, and exit stairways and ramps. It's also required in buildings that require 2 or more means of egress at interior and exterior stairs, ramps, and exit passageways, vestibules, and areas on the level of exit discharge used for exit discharge, and at all exterior landings for exit doors that lead directly to the exit discharge. And because access may be necessary during emergencies, emergency illumination power is required at electrical equipment rooms, fire command centers, fire pump rooms, generator rooms, and public restrooms larger than 300 square feet. Exit signs and markings are perhaps the best tools to help occupants find an exit. Generally, exit signs are required at all exit and exit access doors. The path of egress travel leading to exits, and even within the exits themselves, shall be marked by readily visible signs that clearly indicate the direction of egress travel whenever the exit path is not immediately obvious. The spacing of exit signs shall not exceed a maximum of 100 feet or the listed viewing distance, whichever is less. Exit signs must be readily visible from any direction of egress travel, which sometimes necessitates the installation of multiple exit signs in one location. Exit signs are not required in rooms or areas that require only one exit or exit access. When approved by the building official, main exterior exit doors or gates that are obviously and clearly identifiable as exits do not require exit signs either. Individual dwelling or sleeping units in Group R1, R2, or R3 occupancies do not require exit signs, nor do Group U occupancies. Day rooms, sleeping rooms, or dormitories in Group I3 occupancies do not require exit signs. And for practical reasons, the seating side of vomitories or openings into seating areas in Group A4 and A5 occupancies do not require exit signs if signage located in the concourse are readily apparent. Exit signs shall be illuminated, so they are visible at all times that the building is occupied. Internally illuminated signs shall be listed and labeled in compliance with UL 924. Externally illuminated signs shall have an intensity of not less than 5 foot candles, and the external illumination shall have emergency power that lasts for at least 90 minutes. In addition to normal exit signs, additional approved low-level illuminated exit signs are required in corridors of Group A, E, I, and R 2.1 occupancies, as well as in all areas serving guest rooms in Group R1 occupancies. The bottom of the sign shall be between 6 inches and 8 inches above the floor. And for exit and exit access doors, the sign shall be mounted directly on the door or on the wall adjacent to the door within 4 inches of the door frame. There are 4 exceptions where low-level exit signs are not required. Group A occupancies protected throughout by an approved, supervised fire sprinkler system. Group E occupancies where direct exits are provided from each classroom. Group I and R 2.1 occupancies, which are provided with smoke barriers to create multiple smoke compartments in accordance with Section 407.5. And Group I3 occupancies are exempt from the requirement for low-level exit signs. Path markings provide even further guidance during emergencies, and additional approved path marking shall be installed at floor level or no higher than 8 inches above the floor level in all interior rated exit corridors of unsprinklered Group A, R1, and R2 occupancies. Such marking shall be continuous except as interrupted by doorways, corridors, or other such architectural features in order to provide a visible delineation along the path of travel. And here we see examples of low-level exit signs and path markings in both light and dark conditions. So now we've discussed minimum requirements for most of the basic elements within a means of egress system. But how is the minimum number of exits or access to exits from a building, floor, room, or space determined? Is the minimum number of exits or access to exits always determined by occupant load? What other factors contribute to the minimum number of exits or access to exits? When multiple exits or access to exits are required, how must they be arranged? how many exits or access to exits are required from an occupied roof. Some of the egress provisions in the 2016 CBC have been combined, and Table 1006.2.1 now indicates that at least 2 exits or exit access doors are required from any space where the design, occupant load, or the common path of egress travel exceeds certain limits. Section 1006.2.1 has 3 exceptions where only 1 exit or exit access door would be required. Individual Group R2 and Group R3 dwelling units, when equipped throughout with an automatic sprinkler system and the common path of egress travel, is limited to 125 feet or less. Care suites in Group I2 occupancies that comply with stringent additional egress provisions that can be found in Section 407.4. And for detention and correctional facilities and holding cells, such as are found in courthouse buildings, when the occupant load is more than 20, refer to Section 408.3.11 for details. So this is the new Table 1006.2.1 in the 2016 California Building Code. Notwithstanding further footnoted limitations, only 1 exit or exit access doorway is required from spaces as long as the maximum occupant loads are not exceeded and the maximum common path of egress travel is not exceeded for both sprinklered and non-sprinklered spaces. Otherwise, if table values are exceeded, spaces must be provided with at least 2 exits or exit access doorways. Table 1006.3.1 establishes the basic minimum number of exits or access to exits per story or occupied roof, based on the occupant load of that particular story or roof. Note that Section 1006.3.2 must also be consulted, because under certain conditions, Tables 1006.3.2 number 1 and 1006.3.2 number 2 can reduce the required number of exits or access to exits for buildings and stories allowed to have only a single exit. Here are Tables 1006.3.2 number 1 and 1006.3.2 number 2. The upper table applies only to Group R occupancies consisting of dwelling units. The lower table applies to Group R occupancies consisting of sleeping units as well as all non-residential occupancies. For both tables, as long as the number of dwelling units or occupant load per story is small and the common path of egress travel does not exceed the maximum limits, the building or story under consideration requires only a single exit. Of course, in most cases, especially on upper floors or in large buildings, multiple exits or exit access doorways are required. Section 1007.1.1 governs arrangement of multiple exits to ensure that they are situated in a manner that facilitates effective egress and ensures that if one means of egress is blocked or compromised, others remain intact. When 2 means of egress are required from a space, they must be separated by a distance that is equal or greater than 1/2 the length of the maximum overall diagonal dimension of the area served. The separation distance is measured in a straight line, except that where interior exit stairways or ramps are connected by a 1-hour corridor, the separation distance shall be measured along the corridor. If the entire building is protected by an automatic sprinkler system, the separation distance may be reduced to 1/3 the maximum diagonal dimension. When access to 3 or more exits is required, at least 2 of the exits shall be separated by the appropriate diagonal dimension, and all additional exits shall be reasonably distributed for effectiveness. In this example, an empty tenant space has two exit access doors, which are separated by 1/2 the length of the maximum diagonal dimension of the space. If the building is equipped with an automatic sprinkler system, the door spacing could be reduced to 1/3 the diagonal dimension. In this example, the office space has two exit access doors which are clearly separated by at least 1/2 the diagonal dimension of the space. If one of the exit access doors were blocked during an emergency, the other is sufficiently distant that it would most likely remain in service. When considering the entire floor, the interior exit stairways are connected by a 1-hour corridor, so the separation may be measured along the corridor path. And the last topic of discussion today is emergency escape and rescue openings. The CBC has a very subtle but significant amendment related to Section 1030.1. References to the single exit provisions of Tables 1006.3.2 number 1 and 1006.3.2 number 2 have been removed from the Model Code, and an additional exception has been added. The net effect is that in addition to the normal means of egress required by Chapter 10, emergency escape and rescue openings are required in Group R occupancies from basements and sleeping rooms below the 4th story. The emergency, escape, and rescue openings shall open directly into a public way or to a yard or court that opens to a public way. The added exception indicates that the emergency, escape, and rescue openings are not required for Group R1 and R2 occupancies constructed of Type 1, 2A, 3A, or 4 construction, equipped throughout with an automatic sprinkler system in accordance with Section 903.3.1.1. Note that this exception does not apply if the sprinkler system only complies with Section 903.3.1.2. Basements with a ceiling height of less than 80 inches or without habitable space that are limited to 200 square feet are also exempt from the requirement. And basements or sleeping rooms with an exit door or exit access door that opens directly into a yard, court, or exterior exit balcony opening into a public way are not required to have emergency escape and rescue openings. The minimum clear width of emergency escape and rescue openings is 20 inches. The minimum clear height is 24 inches. And the bottom of the clear opening shall be located within 44 inches of the finished floor surface. Regardless of the opening's height and width, the net clear opening shall be at least 5.7 square feet, except for emergency escape and rescue openings on the grade floor level, which require a minimum of only 5.0 square feet. Note that openings which barely meet both the 20-inch minimum width and 24-inch minimum height provide a net clear opening that is too small to satisfy the 5.7 or 5.0 square foot parameter. And with that, we conclude the 2016 CBC Means of Egress Part 1 presentation. Thank you for joining us today. If you would like more information related to means of egress, you are invited to view Part 2, Part 3, and Part 4 of this series. If you would like to suggest a training topic, please feel free to submit your suggestion to the Los Angeles Basin chapter of ICC at icc-labc@outlook.com. Thank you.